So today I'm going to kind of talk about the UI of AI, and really my intention is that the UI of AI is no UI. The intention is we use other things than the kind of voice and visual UI you guys are all used to. I'm going to share some examples from the automotive industry and how the complexity of using vehicles has become very complex and created a huge cognitive load. So I'll go ahead and go through, this is the journey of what we're going to do. I'm going to explain to you how automotive interfaces have become overly complex and that has presented a problem where drivers have increased cognitive load, how we can use some different interaction modalities to overcome this. And finally, by the end of this presentation, you'll understand what no UI actually means. I'm going to go through this in depth throughout this whole presentation, but I just wanted to introduce some of the key tenets. You don't need to know what these are now, but you will by the end of the presentation. The first is respectful expectation setting. The next is shift from interaction to intention. Be proactive and predictive. Invisible operation with effective error recovery, and then the outcome is the interface. So I wanted to start where it all began. This is basically the first horseless carriage, and let's talk about how you operated this vehicle. You didn't have a steering wheel, you had a tiller, which you kind of moved back and forth to aim the vehicle, and then you had this lever. Pull the lever forward to go forward, pull the lever back to stop. So actually very low cognitive load at this point, but definitely not at all the kind of car operations we're used to. This is a Ford Model T. Now we're looking at what we might be used to, right? Steering wheel, gear shifts, etc. However, when you look into what this is, it's completely different. So this lever on the left is a ignition. You can advance or slow down the ignition for the timing. You think, oh, cool, now we have these cool pedals on the floor just like I'm used to. Not at all what we're used to. The pedal on the left is actually to shift from forward to reverse. The pedal in the middle is some sort of gear shift, and the pedal on the right is actually the brake. Well, that doesn't make sense at all. And then the way that you control the speed is you use this lever. Pull the lever up to go faster, pull the lever down to go slower. So still, in fact, this is really difficult. I would think this would be really hard to drive. And then you think, oh, cool, so we finally have a speedometer. Nope, that's a oil pressure meter. Now we're going to move forward to 1951. Not too much to tell you about this particular dashboard other than it's really beautiful, and I wanted to make sure I put it in our in this deck. But at this point, we are getting more used to the modalities we're used to driving in today's vehicles. Another cool one I wanted to put in just because it looks cool is this Maserati boomerang concept. At this point, the automakers are really trying to focus the driver's focus just right into the center. This was never really released, but it's a cool kind of concept to really put all the important features right in front of the driver. But in 1978, across the pond, Citroën actually did develop something like this. On the left-hand side is all of your heating and environmental controls, and then on the right is your indicator controls and other things. So we're really creating kind of a user-centric driver experience here, and it's actually pretty cool. So now I want to move forward to kind of modern generation of cars, and for the older people in this room, these are probably the cars that you grew up with. This is Louis' 1978 Oldsmobile Cutlass Supreme with some badass rims, but start to picture yourself now driving because that's the generation we're getting into. I wanted to talk about the 1984 Chrysler LeBaron, and in this vehicle they actually introduced something called electronic voice assist.
Your fuel is low. Your engine oil pressure is low. Prompt service is required. Your washer fluid is low.
Okay. The problem with EVA is that it was completely ineffective. What would happen is you would go look to see, oh man, I got to check my oil pressure. The car just told me it's low. The oil pressure is perfectly fine, and so is the windshield wiper fluid. The other thing that people constantly heard from EVA is the door is ajar. The door sensors would go bad, and the car would continuously tell you that the door was ajar, which is extremely frustrating. What would happen is people would just disable this feature. They would go into the car and take the fuse out of the fuse box, and that then disabled a bunch of other safety features. So this is just kind of one of the failures I wanted to highlight. Don't know how I can get past this. All right, we don't need to hear that again. Okay, let's now talk about the Buick Riviera. This was an interesting vehicle because this is the first time where they introduced a touchscreen. So that touchscreen in the center. However, there's tons of problems with this touchscreen. Touchscreens increase cognitive load. If they're not well organized and the visuals are not clear, it's very difficult to find what you actually want to press. There's no haptic feedback. There's no instruction. So what happened was people were trying to, change the radio or get the heat increased, and they had multiple levels of menus to go through. It was extremely difficult to understand how to navigate the vehicle's usability, and this was quickly abandoned. I wanted to highlight on the right-hand side the Apple's liquid glass, where they have kind of created this icon system that visually reduces all sorts of ability to quickly differentiate between icons and makes it very difficult. Just wanted to highlight that touchscreens are really cool for Hollywood, but the cognitive load for humans is great, and they don't always work. And as you can see in this video, or this meme, he's not really actually doing anything. He's just waving his hands around and looking around. There's not actually any UI happening in this video. So hopefully I have explained to you how cognitive load can be a difficult problem. And I need to define what cognitive load is at this point so we all understand, and we can now then move forward. So cognitive load rises from the way information is presented or from unnecessary interactions that don't contribute to the task at hand. So we're presenting the user with lots of fluff and things that aren't helping them get to the goal of what they're doing. So I wanted to now talk about the Cadillac Lyriq. So this is a vehicle I rented. It's an EV I rented when I was at Google I/O. And if the Torment Nexus was a car, this is it. This is a quote from Consumer Reports. She was talking about a different vehicle, but I want to explain really what that means, because this car really demonstrates the huge amount of cognitive load that drivers of modern vehicles have to deal with. So it looks pretty good. It's a nice modern dashboard, right? Lots of screens and buttons and cool things to interact with. It really looks pretty hot and cool in this picture. However, there's a huge amount of information clutter. All these screens are telling me much of the same thing, and they are presenting me with too much information. There's way too much cognitive load for me to be able to focus on the things that are important to me. The steering wheel itself had a bunch of different buttons on it. Some of them clicked when you pressed them, some of them didn't. So it was difficult to know based on haptic feedback when your inputs were actually being registered. Additionally, this car had a feature in the seat that buzzed. Every once in a while, maybe when I had accidentally gone over the lane marker into the next lane, it buzzed. That was kind of cool. It buzzed all the time. It buzzed when I pulled into the parking lot. It buzzed when I was pulling out of the parking lot. It buzzed when I was just sitting there. Extremely annoying. And if I owned this vehicle, I would disable that just like people did with the EVA in previous vehicles. I would disable that with a wire clipper if that's what it took. Finally, maybe not finally, but another important thing is menu navigation. This car had 100 different ways to do the same thing. I could use a knob in the middle, I could use different touchscreens on both sides of the driver, or I could use the steering wheel, or I could use voice. All of those different modalities were extremely confusing and difficult to really know which of the things I needed to do to get my task done. That's just the vehicle. I'm not even talking about the other things that are in the environment when you're driving a vehicle. This vehicle had auditory overload. Whenever I was close to a person on the street, it would beep. Whenever there was another car close to me, it would beep. It was constantly giving me audio notifications that became quite problematic and annoying. Voice command failures. So if I did decide that that was the modality I wanted to use and I asked it to do something, frequently it failed. And that can be very frustrating when you're trying to do something and you can't get that done. And then the last important thing that I don't want anybody in this room to forget about is the challenges of actually driving, dealing with people in the road next to you or other vehicles on the road. There's a lot going on and a lot to pay attention to, and creating an environment like this is challenging. So let's talk about some of the sources of cognitive load. Hopefully you can become aware of them and avoid them yourself. And again, I wanted to give Apple credit for this lovely image of their liquid glass, which really demonstrates increased cognitive load. First of all, choice overload. I mentioned that a second ago. Having too many options to do something is challenging. Visual clutter and poor hierarchy can create problems when a user has to search for what they want to do. Ambiguity, if there's too many ways to do something or we don't know what it is that we're doing, it creates problems and creates challenges for the user to have to understand. Inconsistent design, if we're not doing the same things consistently in every place, the user has to learn different patterns for every interaction they're doing, and that's no good. Poor readability, having icons that don't have distinct colors or that aren't visually distinct is hard for the user. And all of these things, when they're not implemented well, they force user memory. So the user has to know the different incantations and button presses they need to accomplish something. And if we're forcing our users to remember how to use our app, that's problematic. All of these things create unnecessary friction. Our goal in UI is to make the user's desires happen as quickly and as seamlessly as possible. So if you are interested in understanding cognitive load, I just wanted to give the professionals in here some tools that are available. This is a picture of the space shuttle, which I think is about as complex as you could get for a driving environment. But NASA has this task load index, which allows you to check your UI and identify using math actual cognitive load of your products. And then there's also something called CTA, which is cognitive task analysis, that will allow you to understand cognitive load. And finally, straight up user testing, using user research, watching your users use your app, and of course biometrics, testing their heart rates and other things to see if you are creating negative feelings. Okay, so at this point, I hope that I have made the case that cognitive load is bad for user experience. And we're going to get into the important part of the presentation where I give you the solution for reducing the cognitive load. And this is what I talked about earlier, which is no UI. So no UI is not something new. This is something that has been a core part of the design hierarchy forever. And there's a saying that perfection is achieved not when there's nothing more to add, but when there's nothing left to take away. Our goal is to simplify the UI down to the least amount of elements so that it is awesome to use and intuitive for the user. So we talked about these things before. I'm going to go ahead and give an example that will highlight exactly what no UI is in in an example to drive that case home. So my example is a futuristic. Did anybody take a Waymo here this morning? It doesn't go to Gilbert. Interesting. So I don't know if you noticed, but in the beginning of my presentation, you did notice the use cases I showed you of cognitive load. I wanted to use the use case of UI driving as the example that I wanted to use of how effective UI is done in AI world. And a lot of these things are done with by Waymo now, which is interesting. Okay, so the first thing I wanted to talk about is respectful expectation setting. So when we're dealing with tasks that have a delayed response or processing output, we want to let the user know that when the result is going to be, we give them the expectation, and we don't keep giving them updates that we're working on the calculation or we're working in the background. We give them the expectation, we let them know when we'll be finished, and when we're finished is going to be the expectation, is going to be the result that the event has been completed. So we also want to shift from interaction to a woman. I'm going to call her Rita, and she has ordered a automated vehicle to take her to her next meeting. A few things that are interesting to note is the doors automatically opening for her when it recognizes her, and when she gets into the vehicle, you'll know tension. So we don't need to. Something I wanted to mention really quick. I gave this presentation to a friend of mine in Germany. And the use case that I'm showing here is that it presents her with a little hamburger that she presses. It's giving her the option. Let me step back for a second. We know Rita, we know the context, and we know that it is lunchtime. So instead of asking Rita in some sort of UI or presentation, are you hungry, Rita? Do you want lunch? We shifted to the intention. We figured that she probably would want lunch, and we present her the option when she gets into the vehicle to get lunch. So instead of asking her, do you want us to research something for you? Do you want us to figure out something for lunch? We shift to the intention because we are going to start using context and situational awareness to know that we can present the user with proactive options instead of having them pull everything. And again, this kind of goes to the same thing. Our systems are now proactive and predictive. So instead of needing the user to interact with our system, we're going to do a lot of things ourselves. So in this particular example, the vehicle, when she walks up, automatically knows that she's there. Maybe it uses the phone location, Bluetooth, and maybe even image recognition to know that it really is her. As she's walking up, the vehicle opens its door to let her in. It wouldn't let any of us in because we're not the people who ordered the vehicle. But it's using environmental cues instead of Rita needing to press the button to open the door or something. It's doing all these things automatically and not presenting the UI to the user. Okay, so for this next one, I'm going to ask if we could turn down the house lights, please.
Lights turned down.
Okay.
I turned it down from an 8 to a 4. Let me know when you want it turned back on.
Okay, go ahead and turn it back on. And quiet. I wanted to demonstrate that in this case, we don't need the feedback from the God mic to let us know that the lights are off. We could tell that the lights turned off. We don't need, and we certainly didn't need the extra information about the intensity of the lights or whatever. The successful result is the confirmation. We're not going to need to tell people that something happened because it actually happens. When Rita walks up to the vehicle, the door opens it up and lets her in because it knows that that's her, it's the right thing to do, and that's the confirmation of the action. There's no nothing else that we need to tell her. The other thing that's important, and doesn't really show up in this presentation, but is really important in user interfaces that have no UI is there's lots of error checking and handling and correction happening in the background. So instead of presenting errors to the user at lots of inopportune times, we correct the error. We use context and decisions within our own system to automatically correct those things. So as I mentioned, there is a real-world example, which is Waymo. Unfortunately, I think I have, let me see. I think that this video won't show because I have, my corporate computer doesn't connect to, but basically what that was is that was a presentation, and it just showed you the Waymo operations because they're doing a lot of the things I presented. When you walk up to a Waymo, the doors unlock automatically when it, based on your interactions with it. It doesn't present you lots of options through the ride itself. It's all very automatic, and no UI. They don't present you with a lot of key things. So let's talk about the key takeaways, and they are: AI interfaces should become less visible. We're not trying to present the user with a lot of different options. We're trying to proactively think about what they might need and present them with those solutions. Minimizing cognitive load is going to be more important than ever as we add all sorts of other features like UI, all sorts of features like AI to our already existing products. We need to really consider how we keep our features easy to use and simple to see. Don't forget to embrace new modalities like voice or lights turning on or off or other things. Use confirmation instead of UI for to give the user confirmation that something happened. Finally, strive for no UI where outcomes are the interface. So that's it. Please reach out to me, and the rest of the conference, and we'll chat about no UI.